Okay, so we are back once again under adding inclined vectors, adding inclined vectors. Now we know that anytime you have inclined vectors that are inclined to each other at an angle, let's say v1, v2, we have to find the resultant vector. We have to find the resultant vector, v. Now we can find the resultant vector by many ways. We can find by the parallelogram concept, the parallelogram law concept. We can find the resultant by the triangular law concept. We can find the resultant by the resolution method. And also can find the resultant by the graphical method. Okay, so now I think in my previous videos we dealt with the parallelogram, the triangular, but this particular one lesson we want to look at the resolution method to find the resultant vector. And the resultant vector is when we add the inclined vectors, what we get. So it's called the resultant vector, the net vector, or the total vector. Alright. So now consider two vectors. Let's consider two vectors. V1 and V2. Let's consider these two vectors, V1 and V2. Inclined at angles θ1 and θ2 with respect to the horizontal, respectively. So now we see these two vectors here inclined, meeting at this point. So these two vectors, V1 and V2. And each of the vectors are inclined at an angle with respect to the horizontal. So this vector is inclined at an angle, let's say θ1. And this other vector is inclined at an angle with respect to the horizontal, let's say θ2. Then we can use the resolution method here to find or to resolve by finding one, the vertical component, and after we sum them up, we sum the vertical component and we can too find the horizontal component. And after we sum the horizontal components out, we sum the horizontal components. So anytime you get the vertical components, that's the Vy, and the horizontal components, and we sum them up, then we can now find our resultant vector. So the resultant vector here is very simple, which we can use our Pythagoras theorem, to find it. So the resultant vector v here becomes root of the Vy squared plus root of our Vx squared. Now the point here is that anytime you have these two inclined vectors over here, vector v2 inclined at an angle of what? θ2 to the horizontal, and you have vector v1 inclined at an angle of θ1 to the horizontal. Now I want to resolve these two vectors. So resolving these two vectors, you have to find one, their vertical component, and two, you find their horizontal component. But take note, the direction of both also matters. The direction of both also matters. Their direction also matters very well. So now what happened here is that to find the horizontal component, the vertical component for V1 becomes, this is the direction, is going up. This also to this the direction. It becomes V1 sine of the angle 1, θ1. And this with the vertical one becomes V1 sine of the angle V2 sine of the angle θ2. V2 sine of the angle θ2. So that's what it means. If you take the V1 for instance, when you complete it, you get something like this, which is V1 here and an angle θ1 here. I get it. So now you can simply go by it and say that to find this horizontal line, which is the horizontal component here. So let's say this horizontal component here is what? Our vin y. This horizontal component here is our vin x. Then how do you find vin y? How do you find our vin y? So our vin y simply here becomes vin y sine. Sorry, vin y is equal to our vin 1 sine of the angle theta 1, as we did in previous videos. So now it's simply sine theta 1 equal to opposite vin y over what? Our hypotenuse. So now finding vin y is vin 1 sine theta 1. So that's how come we got this. And the same thing if we do for the 2, you can find x what? Or vertical component. Okay. Now the horizontal component you can find here. The horizontal component you can find here. So now since the direction is this way, it is inclined in this direction. The horizontal component direction is what? The vertical component here, the horizontal component direction is here. So the direction is this way. And this one, since it is this way, the direction is what? Horizontal component direction is this way. So now if you do this, you get v1 cos of what? Theta 1. And if you do this, you get v2 cos of what? Theta 2. So now if we resolve them into their vertical and horizontal components. Now what happens? What we are supposed to do here is that we have to find the total vertical vectors. The total vertical vectors. And total vertical vectors is what? v1 sine of theta 1 plus v2 sine of theta 2. And these are total vertical vectors. We have to find our total. So our total vertical vectors, let's say it's called our vy. Total horizontal vectors are vx. So from here, you realize that the directions are changing. So therefore, you have to subtract one from the other. So v1 cos theta 1 minus v2 cos what? Theta 2. If the directions were the same, then it would have been plus. Okay. So now getting this, how do you find the resultant vector? So now we can easily find the resultant vector. So now what happened here is that we are getting something of this nature. After the resolution, we are getting our vin. So the vin y is now equal to vin 1 sine theta 1 plus v2 sine theta 2. And our vin x is now equal to v1 cos theta 1 minus v2 cos what? Theta 2. So therefore, our vin is equal to root of vin y plus v square y plus vin x squared. And vin is equal to, what is our vin y? So vin 1 sine theta 1 all squared. So I should vin 1 sine theta 1 plus vin 2 sine theta 2 all squared plus vin 1 cos theta 1 minus vin 2 cos theta 2 all squared. So now this value you get here is your resultant vector. How you can use the resolution method to find a resultant vector? When we have two inclined vectors inclined to each other at a point, subtending angles that mix with the horizontal. When you do this, and you want to find the angle theta, or you want to find any of what? The direction of the resultant vector. So when you resolve this way, you don't know the direction of the resultant vector. So to find the direction, so let's put it here, finding, after resolving, finding the direction, so either the direction is here or the direction is here, you don't know. So you want to find the direction of the resultant vector. How do you go about it? So the direction of the resultant vector is simple, which is the tan of, if you know the angle here, which becomes, so if we put the angle here, we want to find this direction, this angle, then it becomes the tan theta of what? Vy on what? Vx, which is what? Alpha is equal to the tan inverse of what? Our Vy, which is this. So Vy, which is v sine theta 1 plus v2 sine theta 2, all on v1 cos theta 1 minus v2 sine what? Theta 2. Okay, and this becomes your direction. Let's take two examples and we use the resolution idea to find it. Okay, so this is the question, and the question is that two forces, 10 newtons and 18 newtons, incline 15 degrees and 20 degrees respectively with the horizontal. Pulls a body in opposite direction as shown. Find the resultant force and the direction of motion of this particular body. So now this is the body here we are talking about, and there's a force of 80 newtons and there's a force of 10 newtons, and this force is pulling the body inclined with, that makes an angle with what? 15 degrees Celsius, and this one makes an angle with 20. So it has to find the resultant force. Okay, so now if you take this as a point where they meet as the body, so here is what? 10 newtons, and this place is what? 8 newtons. So you have, and the angle, you are making an angle here, this 20 degrees, this 15 degrees. Okay. Now we've gotten these two angles now. Okay, so now we have to resolve them. So resolving them, we resolve them onto the horizontal and the vertical components. Take note of the direction. This is going this way. It's going this way. So this will be X direction, and this will be X direction. Can you see it? So now the focus here is what? This point. So therefore, the horizontal, the vector here, the vector will go up, and this one will go this direction. Take note, I said always the forces that makes the resultant will not touch the backward direction of the resultant. They always go forward. So this one also makes the direction this way. Okay, now let's look at this one, which is this. This direction is here. Okay, so there's the meeting point, and this also go this way. So now we get the direction here, and we get the direction here. Okay. So if you are able to build this direction, then you are true. So now just use the idea. Resolving this becomes what? The vertical is sine of what? The angle. The horizontal is cos of the angle. So now it becomes what? 10 times sine of what? 15 degrees. Here becomes 8, this one, times sine of what? The 20 degrees. Anytime you do this, it will really help you. This one becomes 10 cos of the 15, and this 8 cos of what? 15. So now use the calculator to punch that. When you do this, you get 2.6. If you do this, you get 2.7. If you do this, you get 9.7. And this, you get 7.5 newtons. Okay. So now, when you're done resolving this, you have freedom. So what happens is that you have to find your Vy, which is the same as your total vertical component. And your Vy becomes, since they are all pointing parallel, they are all pointing towards the same direction. It is 2.6 plus what? 2.7. And that will give you 5.3 newtons. So you find your Vx, which is the total horizontal component. But this time they are all pointing towards different directions, and they are parallel vectors. So what you get is you subtract it. So this is higher than this, so therefore it becomes 9.7 minus 7.5. And that gives you 2.2 newtons. 2.2 newtons. So now, since you are done now, you can redraw your diagram and you find your resultant force. So to find your resultant force, your Vy now is what? 5.3, and your Vx is what? 2.2. Take note. So your Vy is 5.3, and your Vx is what? Is 2.2. So what you do here is that since your Vy is 5.3 and your Vx is 2.2, what you can do here is that your resultant force F, and the F squared is equal to what? So let's say Vy squared plus what? Vx squared. And that gives you 5.3 squared plus what? 2.2 all squared. And when you do this, you get your f squared to be, you get your f. So if you do this, under root is equal to what? So therefore your f now becomes 5.74 newtons. But take one thing here. The resultant here of the vertical one was what? Going up at what? Vy, which was 5.3. So this one should go up. To find the direction, that's why I'm telling you this. And this one here went here. So the resultant here, because this one was larger, and we got the 2.2, the direction has to face here, not here. So we get here as 2.2 newtons. So to find your resultant, depending on the direction you take your resultant. So we take our direction here, 5.5. You have to negate this side. So our Vy now becomes negative, which is negative 5.31 newtons, so that you can change the direction also here. Can you see it? But I didn't do it because if you change it, negative 5.3 will still give you what? The same value, and you arrive at the same answer. Do you get it? But to find the direction, you have to make sure you do this very well. So now the direction here, let's say this is our theta, now becomes tan theta is equal to negative 5.3 all divided by 2.2. So therefore theta is equal to tan inverse of negative 5.3 divided by 2.2. And when you do this, you get your theta as 67.38 degrees. 67.38 degrees. Thank you very much.